Good morning, students. Welcome to another session on continuation of circle diagram. In previous classes, we have seen the basic things of circle diagram. From circle diagram, we have known how to calculate various parameters. Okay, so what are the parameters we have seen previous classes? Okay, so what are the parameters? So we calculated what is the output, what is the input, what is the pixel losses, what is the rotor copper losses, or what is the stator copper losses, and how to find the efficiency, how to find the full load slip, and at the same time what is the rotor speed also we performed. Okay, so based on this basic knowledge, so we are going to do one practical problem by conducting OC test and open circuit test, that is a no load test, and a blocked rotor test. Okay, so here one problem is given. Okay, so let us assume this is a one motor. So new motor I purchased. I want to know its efficiency, percentage efficiency based on versus the load current. At that condition, what is the different parameters values? Okay, let us do it. Now the problems on given a problem. What is the problem is given? So draw a circle diagram of a 20 HP. So is given how much? So there is a one motor is given here. Okay, so this motor rating is nearly 20 HP. Output line purpose I require this one. Okay, next, so total power, output power. So output power is equal 20 HP motor. Okay, now 400 volts. So VL is given 400 volts and 3-phase star connected. Induction motor, from the following test data, all are in values. So from no load test, so what is happened? So what are the no load test? We conducted belt is loose and we connected 3-phase parameters. We found that this is equal to no load voltage, rated voltage is applied by using the variac. Okay, then so ammeter indicates the what is the current and power factor. So W1, W2 will use the power. At the same time, from this is directly given the power factor. It's a very easy. Instead of calculating the angle, it directly is given the angle for circle diagram. Okay, now second test, block rotor test. The rotor is tightened with help of the springs. Now at that condition, we given the rated current. What is the rated current? 50 amperes. At that condition, voltage is 200 volts, and at that condition, the power factor is 0.4 only. So these values are given by conducting tests on a given induction motor. Okay, now what is asking? Find the following values from the circle diagram. What is that one? Line current is asking. What is the finding? Is asking the, okay, so line current, power factor, slip, efficiency at full load. At the same time, so another is asking also maximum power output in HP. So these are the required values. Okay, so let us do two tests on a given motors. So what is given? A solution from the no load test. The data is given as, so what is happened here? So once again I am repeating. So give the rated voltage by using auto transformer, and here the belt should be loose, that means they are free to rotate rotor. Then give the rated voltage, find the what is the current, find the what is the voltage, find the W1, find the W2. So based on this one, ammeter will give the current, rated current, no load current, that is equal I0, and voltmeter will give the voltage, rated voltage, and so power it will give the W1 plus W2. 3 readings we will get it. So what are the gets? This rated voltage is equal 400 volts, no load current is equal 9 amperes, no load power factor cos phi is equal 0.2 lakh. Therefore the cos inverse of this is equal, we are going to get the 78.5 degrees. Okay, now what is the current? I0, I know the I0 value at an angle of phi 0. Okay, that is equal 9 amperes magnitude at an angle of, so I am going to 78.5 degrees. I know the from, I can write it this one. So this angle is equal 78 and magnitude is equal to, that is equal I0, this is point A from this diagram. Okay, and similarly from the black rotor test you perform. From black rotor test, so in this case what you are going to do, that tighten the belt with help of the springs. The rotor speed is equal 0 in this case. Now give the rated current to motor. At that condition, what is the voltage, what is the W1, what is the W2. Okay, so from that you are going to get it these values. That is the VSC, rated voltage is 200 volts, and short circuit current, rated current is equal, that is equal to 50 amperes. Now short circuit power factor is given directly 0.4. From this I am going to calculate the phi SC is equal 66.4. So from this, so I am going to get it the angle. I know the ISC at an angle of phi SC, but I require the ISN, normal voltage, at angle of phi SC. Okay, so how to calculate it? Here we applied the only 200 volts. Okay, but if I given the rated voltage 400 volts, what is the this current? That is the ISN. Okay, so that purpose, just you know that you convert it, the short circuit current for normal voltage. So simply you find first the value. Okay, so that is called short circuit current for normal voltage, that is a 400 volts. So what is the formula? You know that ISN is equal to ISC into V1 by WS. This is a well known formula. Okay, so what is the ISC? 50 is given, that is a short circuit condition. Black rotor rated current is the 50 amperes, and what is the rated voltage? The 400 volts. What is the short circuit? What is the reading of the VSC? That is the 200. Doing this one, I am going to get it. This is a 100 amperes. That is equal, ISC is equal to 50 amperes when 200 volts is applied, and ISN is equal to 100 amperes when the 400 volts is the normal voltage applied. So this is the value. So I know that ISN and at an angle of phi SC. So second, this is also we know, this is also, this is a B, OB, and this is a OA. Now these two values are, we got it. Okay. Now current scale, convert the current scale. So that means here the 100 amperes, this is amperes converted into length. So previous cases, what is the no load current? No load current is equal, what is that one? That is a 9 amperes. Okay, 9 amperes is the no load current, and short circuit current is equal to nearly 50 amperes, and short circuit current under normal voltage is equal 100 amperes. Then based on these values, just choose a one scale. Let us assume 1 centimeter is equal 5 amperes here scale. Okay, you take it orbital, you can take it as per your convenience. Therefore, whatever the no load current, 9 amperes divided by 5, you are going to get the 1.8 amperes. Sorry, 1.8 centimeter length, we know that. Okay, so if you know this one, so this is the O, and magnitude is a 1.8 centimeters. Length is the this length is a 1.8 centimeters. What is the angle? Angle is equal, so that is equal 78 plus something now, as it will come. Okay, so this length I can calculate it from this one. Similarly, so I want the ISN also. So ISN is equal 100 by 5. So I am going to get nearly 20 centimeters. Then I am going to get this is 20 centimeters. This is the length is the, this is the B, this is the A, this is the 20 centimeters, this is the, what is the matter? 5, that is equal 1.8 centimeters. Okay, that is one. The circle diagram is drawn to the EPO scale. Based on this one, we can write it. Now, similarly, you calculate the short circuit current power. That is the another step. So, SC power, short circuit power, WS is equal. So, we know the root 3 VL IL cos phi. Okay, so root 3 we know that. So, VSC we are going to calculate short circuit current is 200 volts, and short circuit current ammeter reading 50 amperes, and cos phi is directly is given. So, from this one we are going to get it, substitute this value. So, wattmeter reading under block rotor test, that will give the nearly this value. That means W reading is a 6928.2 watts is given. Okay, so this is the wattmeter reading. Directly we will get the wattmeters from this one, but in this problem is indirectly is given the power factor. Okay, so anyway we calculated this also. Now, short circuit power for the normal voltage. This is the voltage we are applied only rated, that is a 200 volts, fraction of voltage. If I given the, instead of 200 volts, if I given the 400 volts rated voltage, then what is the power? I am going to convert it. That purpose we know that I short circuit at normal voltage is equal to WSC, so this volt into V by VSC whole square. This is a formula. Okay, this is equal to 400 volts, this is equal to 200 volts, and WSC we calculated from this one. Then I am going to get the short circuit power for normal voltage. Okay, so this is the procedure. So you know, simply substitute this value, and you are going to get the 2713 watts. Or I can use my basic formula also. So what is the basic formula? So WP is equal to root 3 VL cos phi. At that condition, so that is a root 3, and VL is equal to 400 volts. ISN is equal to, with the normal short circuit ISN, we can write the ISN, that one. ISN is equal to 100, and the power factor is equal to 0.4. So by substitute this also, we are going to the same WSN. So this are two methods. You can substitute this basic thing, but remember that ISN, not ISC. Okay, based on this one, you are going to get the now WSN. So here WSN is also same. So based on this WSN at an angle of, what's the 68 degrees. So I can get the point from 0 to B point. Length is equal this much, and angle is this much. Now here length 2713 watts, but what is the length? Centimeters. That purpose we convert 1 centimeter is equal to how many watts. Okay, so that required. Now this power is equal to the length of the line BG. So now, so based on the line diagram, so previous diagram what we have seen, here draw the everything. So draw the circle diagram, you know, draw the OA. So based on this one, what we are going to do? Okay, so how you have drawn? So from the OA is given values, okay, and OB from the short circuit condition, join the, so what is, so I am giving here. Okay, so don't bother. Here what is happened? So from current scale, this is equal to X, this is equal to V, reference one. Okay, now I0 is equal to how much is given? that is equal, we got it. So this is the O, length is the 1.8 centimeters. Okay, this is the 1.8 centimeters length, and this is equal to, represented as a at an angle of 68, that is the 78. Now what is the angle? So is given, that is equal nearly 78.5 degrees. Okay, we got it, A point. This is the A point. Okay, now from the short circuit test, so you are going to write the another. You can take the another. Okay, now so another, what is the angle? 68. Okay, what is that one? 66.4. So from this one, 66.4, what is the length? So nearly how much length? So we are going to 20 centimeters. Okay, the 66 point, this one, I am going to get it. Length, what is the length? Nearly, that is equal B. Length is equal 66, 20 centimeters. This area is equal, what is the, that is equal 66.4 degrees. Okay, this is the red color, we got it from the Noload test, and blue color we got it from the blocked rotor test. Okay, draw it. After A and B, simply join this line. You know that. Please simply join this line. Okay, then draw the one horizontal line here. Okay, now bisect the AB, then you are going to get it here. So represent, this is equal C. From A to C, draw the one circle diagram, semicircle. Then from here going to get it semicircle. Okay, now you know this one, and from this one we draw the one another B2, draw the one vertical line. Okay, so from up to this one you write it. Similarly, you can see the up to G, this is equal G, this is equal P. Now this is equal F. Okay, now you know you require the copper loss is equal stator copper loss. You know that thing. So based on this one, you divide. Let us assume here this rotor copper loss is equal to stator copper loss. Whatever the wattmeter is given in short circuit condition, divided by 2, we are going to the this length. Rotor copper loss is equal stator copper losses. Okay, so from this one I am going to get this loss. So everything this value. Okay, now okay, so what is happened here? I want to know that, so length of the BG. So find the what is the length from this to this, what is the length, calculate it. So if you are knowing the length from BG length, B to G length, so I am going to get nearly, so what is the 8.1 centimeters. By measuring length with a scale, I am going to the 8.1 centimeters BG length. Okay, so now therefore the power scale is, what is the power scale? Already we know that. So total power already we calculated. What is that one? That is equal to 1 centimeter. So we got it, that one. So already VWSN is equal to 27,713 point. Okay, this is the watts we calculated when the normal voltage is given under short circuit condition case. So we are going to get it. So how much? That is equal 2713 watts. This is the watts. I want in terms of length. So here we are going to get it. 1 centimeter is equal to, then we are going to get 27,713 divided by 8.1. Okay, then I am going to get it some value that is equal 3421.36. So this is a length power scale. What is the power scale? 1 centimeter is equal to 3421.36 watts. Such a way I calculated the power scale also. Okay, so power scale how we are calculated? So based on WSN total power, I got it from the wattmeters. If I assumed voltage is a normal voltage, and I calculated the length based on a given tables, and this by this total length I am going to get the 1 centimeter length. Okay, so we got it. So after getting this value, okay, so now I require the full load torque. So full load torque means how to we got it. The full load torque means here what you are going to get. So I require this value. From this value I want this value. Okay, so how we are going to get it? So that can be, okay, you can see here animation. So here what you are doing? So now this power is equal to the length of the BG, that is called this length. What is the length? So this length is equal to 8.1 centimeters. Okay, now therefore the power scale is equal to, so that is equal to 27,713 by, so we got it this scale. Now the full load output of the motor 20 HP is given. We convert into the watts. So this is the power. Once again we convert into the scale. So the total power by this scale 1 centimeter. What is the power? Total power is the full load power is equal to 14710 watts. Then 1 centimeter require 1 centimeter. So divided by this much. What is that one? 3,421.36. I am going to length. Okay, so that length is equal nearly 4.3 centimeters. This is the length. So from B2 I extend the line up to the length equal to 4.3 centimeters. Okay, so that is the full load output of 10 HP motors. Length of the full load output on the diagram is given. So B, you can say this the L. Okay, from BL you draw the one parallel line with the output line. Then you are going to the this is a P. Already we have seen. Okay, we will see that next class. Next, let us assume stator and rotor copper losses are equal at a standstill condition. Okay, now therefore BE is equal to EF. Here both copper losses are equal. Now here what is the rotor copper loss is equal to the stator copper losses, both are equal. Now extend the BG further up to L. So what is the distance? That is equal to nearly 4.3 centimeters. Okay, so 4.3 output of the motor. From the point L, draw a line parallel to the output line. What is the output line? AB. Okay, so output line, and to intersect the circle diagram at P. So here where is the P? P is here. Okay, the OP, now join the line from O to, so from this to this join the one line. So OP represent the load current at this output. Okay, so here from the circle diagram we can find out the following quantities. So this total, now we have drawn total required circle diagram. Now let us find that from the circle diagram we can find the following quantities. Now full load line current I required FL full load. So I can measure the length from O to P. So that is going to get the current, and the current into, so I am going to get the centimeters into current scale. I am going to get the what is the value of that thing. For example, I can measure the length OP. So line length OP I am going to get the 6.2 centimeters. Then what is the power? So because 1 centimeter is equal to 5 amperes, then how much of the 6.2 centimeters? Then 6.2 into 5, so I am going to get nearly 31 amperes. So this is the full load current of the motor. If load is added on this motor full up to the full, it will draw the 31 amperes from the supply. Okay, So simply just measuring the length OP, and we know what is the full load current. At the same time, I require the power factor. At this condition, what is the power factor? I can easily calculate what is the power factor. This is the power factor, this is the angle. Cos of this angle I am going to get the at that condition. Very simple. Okay, so we'll see. Find the full load power factor. Here the phi 1 angle, that is equal from the V1 OP, angle of V1 OP is equal 31 degrees. By measuring the compass, so I can get the 31 degrees. That means the current, what is the current here? So the current, the full load current is equal 31 amperes. Okay, 31 amperes at an angle of, so I am going to get it, what is the value? That is equal 31 degrees. This is the full load current. Simple, by measuring this one I am going to get this one, measuring the length, magnitude, I am going to get this one. Okay, now full load power factor cos phi. So cos 31 we are going to get the 0.85 lakh, that is the power factor. Or we can also calculate cos phi 1 is equal to, what is the cos phi 1? Here this is the angle, this is the required. So what is, you are going to pk value, pk, this is a value, this is a value, and this is a value. So I want the power factor. So this is O, P, okay, this is the K. Okay, angle is this one, this one. So then nothing but this one. This is called cos phi. Okay, this is the pk value I required. So cos phi is equal to pk by OP. So that is equal, the length of pk length is equal, what is the pk? So pk length is equal, we are going to get the 5.3 length divided by, so OP length is I am going to get is 6.2. So then I am going to get the nearly 0.85. So this is also another method to find the power factor of induction motor. Okay, so as you like, you can do any one method. Now after that, so you are going to calculate what is the full load slip. Okay, full load slip. So if added the load on the motor up to the full condition, at that condition what is the slip, what is the rotor speed, I want to know. Okay, then the full load slip S is equal to, from P2, what is the copper losses is equal, the copper losses is equal S into P2. The P2 is the rotor input. So rotor input nothing but, so what is the rotor input here? So rotor input is equal simply Pn. Okay, Pn, that is equal up to the P point to N, up to the torque line. What is the length? You measure it. So then we can easily calculate it. Then the full load slip S is equal to rotor copper loss by rotor input. So what is the rotor copper losses? Rotor copper losses is equal to Mn. Where is the M? So M is equal to here. What is the N? Here. So this is the rotor copper loss divided by rotor input. What is the rotor input? That is equal to nearly Pn. Where is the P? This is the P. What is the N? So N is this one, this length. Okay, so you are going to get it, that is equal to length. You find that what is the length of Mn. Mn, you measure it small this distance, that is equal 0.3 centimeters, and measure the total length up to P and N, you measure the length, then we are going to get the 4.6. So then 0.3 by 4.6 we are going to nearly, so that is equal 6.5% slip. Okay, 6.5% slip. Motor is running under full load condition. Okay, now after knowing the full load slip, I want to know the another factor, that is equal, main factor is equal efficiency. So how to find the efficiency? So we know the efficiency is called output by input. What is the output here? the output is equal to output by input. So output is equal PM. Okay, so where is the P? So you are going to do that is a PM is the output, and PK is the this one. Okay, so that is equal, efficiency is equal to output by input. Okay, so into 100, that is known. What is the output here? So PM up to output line divided by what is the input? PK, total this thing. Then you are going to the efficiency into 100, then percentage of efficiency you are going to get it. Okay, so now what is the length? Find the length. PM length you are going to get it. So what is the length of the PM? So that is equal 4.3 centimeters. You measured the length. Okay, then what is the PK, total length? That is equal, I am going to get that 5.3 centimeters. Okay, into 100, then we are going to get nearly 81% is the efficiency. Okay, so dear students, while doing the calculations, while measuring the length, you should take the accurate values. Okay, so only the efficiency depend on the length 4.3 by 5.3. Okay, so while doing this measuring these values, you take the mm also. Okay, so this is the efficiency. The efficiency is equal to output by input into 100% efficiency, PM by PK into 100. PM is the length 4.3 and PK length is the 5.3 into 100. I am going to get the efficiency 81%. So now we can see it under full load condition. So I am going to get it. What is the current? Full load current. So full load power factor. The full load current, I am going to, what is the value? So here, so without actual load, I can know what is the full load current. That is called nearly 31 amperes at an angle of, so nearly what is the power factor? That is equal 31 degrees. That means the power factor is equal to, I am going to 0.85 lag. Okay, because induction motor. At the same time, I can slip also at that condition. I am going to 6.5%. Okay, then at that condition, I can know the what is the efficiency at that condition also we calculated. So see the beauty of the circle diagram, dear students. Without performing actual load, so by conducting basic 2 experiments, I can know the what is the full load current at that condition, what is the angle, what is the power factor, what is the slip, percentage slip, what is the percentage efficiency I can found. Okay, so this is things that is the useful of the circle diagram. Now after basic things, now I am going to find that the extreme values, that is the maximum output, maximum torque, maximum input. Okay, so simply draw the tangent lines, parallel lines. So based on the tangent, so measure the length. From these values we are going to find it. Okay, so maximum output I want to know. So maximum output, so where is the maximum output? So draw a tangent with parallel to the output line, the AB output line, and then it touches at H. Now H, and draw the one line from H to up to the output line. Where is the output line? The AB, that is equal I. Now what is the length? HI length. Measure the length. Measure the length. So what is the distance? You are going to get 6.4 centimeters. So you know the power scale, 1 centimeter is equal to 3421.36 into 6.4. You are going to get it the actual value. Okay, so you can see here. So length into this value, then we are going to get this 21,897 watts, that is called 21.89 kilowatts. This is the maximum output of the machine. Okay, so now coming to the maximum output in HPs. So he asked the HP, simple, divided by 735.5 or 746.5. You can, whatever the value, you can divide it. So you are going to get it. That value is equal to nearly 29.77 HP. That means nearly 30 HP at that condition maximum. Okay, so what is the given? So nearly this machine rated. Okay, so this is the maximum output power in HP. So nearly 30 HP it will gives the maximum. Okay, so these are the required values. Now I require the full load slip. What is the slip? I want to know it. Okay, from the full load slip I can easily calculate what is the full load speed also. Okay, so that purpose I require the full load slip. So we know that what is the full load slip. So I can calculate the full load slip here. Already full load slip already we calculated. Okay, so now, so what we have seen in this class, okay, with this problem, so what we have seen, so let us summarize this thing. So first we calculate the I0, that is equal no load current at an angle, short circuit current at an angle, and short circuit current under normal voltage, that ISN at this angle you find it, and proportionate calculate the ISC and WSN, and current scales we calculate. So what is the length of I0 ISN? In a flat I0 ISN, draw a output line, bisect the output line, draw a semicircle from the point on the reference line, drop a perpendicular from the point on semicircles to reference line, and divide the line into half, join the center to starting circle. That is the torque line. So here the torque line we are assumed the copper losses is equal to the copper loss of the stator equal to the copper losses of the rotor. Okay, from the center of the semicircle draw the perpendicular line, and we are going to get it so maximum torque and maximum output. Okay, this is a simple method. The same method can be followed in this problem. Okay, so if you are practicing this one or two problems on a given graph, so you are very familiar how to draw the circle diagram. Okay, so let us summarize. So we have drawn a circle diagram and find out ISN, that is equal ISC into V1 by VSC, that is the short circuit. So while doing the block rotor test, you are going to get it the wattmeter reading, that is equal short circuit current under some fraction of voltage only, but I require the short circuit current if I given the full load voltage is given to the motor, that is called ISN. You calculate based on this formula. At the same time WSN also you calculate it. After that line current OP, slip at the full load, power factor at full load, maximum output, and efficiency at the maximum load also we calculated. Okay, so dear students, so based on this basic knowledge, the practice on a given real graph. Okay, so if you face any problem, discuss same problem in the next class. Okay, so I think this is how to draw the circle diagram from given values. Okay, so thank you for listening my class and practice perfectly. Okay, thank you.